Imagine standing at the edge of the Sahara Desert. The sun is brutal, the air is completely dry, and in every direction there is nothing but sand. No water, no trees, no life. Just an endless ocean of dust stretching further than you can possibly see. Now imagine standing at the Congo River, roughly 2,000 miles to the south. The water here is so abundant, so violent, so impossibly powerful, that the river dumps more than 41,000 cubic meters of fresh water into the Atlantic Ocean every single second. Every single second? Water that nobody uses. Water that just vanishes into the salt of the sea, while millions of people to the north are slowly dying of thirst. Here is where the story gets interesting. For decades, a group of engineers have been working on a plan so audacious, so breathtaking in its ambition, that most experts who first heard it assumed it was a joke. Their idea? Build a man-made canal. Nearly 2,400 kilometers long, capture those billions of cubic meters of water from the Congo River basin, and send them flowing northward across jungles, mountains, and borderlines until the water reaches the dying heart of the Sahara and brings it back to life. This is the story of Project Transaqua. And the closer you look at it, the harder it becomes to decide whether this is the most brilliant engineering vision in human history or the most dangerous gamble our civilization has ever considered. The Sahara Desert covers roughly 9 million square kilometers of the African continent. That is an area almost as large as the United States. And when people talk about drought in the Sahara, they are not talking about a dry summer. They are talking about a place where some regions go years, sometimes decades, without a single drop of rain. The soil is so parched and hostile that nothing grows, nothing survives, and the desert is not sitting still, it is moving. Every year, the Sahara creeps southward by several kilometers, swallowing farmland, burying villages, and erasing the boundaries between where people can live and where they cannot. This creeping catastrophe is called desertification, and it is one of the most underreported environmental disasters happening right now on planet Earth. In the countries that border the southern edge of the Sahara, the region known as the Sahel, farmers wake up every morning to find that the land they have worked for generations is turning to dust beneath their feet. Wells run dry, cattle die, harvests fail, and the people who depend on that land have nowhere to go. Meanwhile, just a few thousand kilometers away, the Congo River is doing something almost obscene. It is throwing away water. The Congo is the second largest river on Earth by water volume, second only to the Amazon. It drains a basin the size of Western Europe, fed by some of the heaviest rainfall on the planet. The river runs so hard and fast that its discharge into the Atlantic creates a zone of fresh water you can detect in the ocean hundreds of kilometers offshore. The Congo does not trickle. It roars, and almost none of that water is being used. This is the paradox that a group of Italian engineers from a firm called Bonifica first noticed in the 1970s when they spread a map of Africa on a table and stared at it long enough to have what can only be described as a wild idea. What if, instead of watching all that water disappear into the ocean, they redirected it to the places that needed it most? The original concept of Project Transaqua, drafted in those early planning meetings, was staggering in its scope. The engineers proposed building a navigable canal, stretching approximately 2,400 kilometers from the right side tributaries of the Congo River northward to Lake Chad. Along the way, the canal would pass through 5 countries, cut through some of the most remote and difficult terrain on Earth, and carry an almost incomprehensible volume of water, roughly 100 billion cubic meters per year. Let that number sit for a moment. 100 billion cubic meters. To put that in perspective, that is roughly equivalent to taking the entire annual flow of the Rhine River in Europe and redirecting it somewhere. Completely different. Or, if you prefer a more visual comparison, imagine filling 40 million Olympic swimming pools every single year. That is the scale of water this project was designed to move. The canal itself was not just supposed to be a ditch. The engineers envisioned something wide enough and deep enough to function as a full shipping route, with widths exceeding 100 meters in places, and depth sufficient for large commercial barges. The idea was that this waterway would not just carry water, it would carry trade, connecting landlocked regions of Central Africa to each other for the first time in history and opening up markets that currently exist in near total economic isolation. But right from the start, there was a problem that no amount of enthusiasm could paper over. Between the Congo Basin and Lake Chad, the land does not cooperate. The terrain rises and falls dramatically, with the highlands and plateaus of Central Africa sitting directly in the path of any water flowing northward. And water, as every engineer knows, does not flow uphill on its own. To overcome this, the Transaqua designers came up with an elaborate cascade system. Rather than trying to pump water over mountains, which would require energy on a truly staggering scale, they proposed building a series of massive dams and artificial reservoirs in the highlands. These dams would collect water from the Congo tributaries and raise it to the necessary elevation, essentially creating a staircase of water that would allow gravity to do the heavy lifting once the high ground was cleared. The water would be stepped up to altitude and then allowed to flow naturally downward toward Lake Chad, following the land's natural gradient. In theory, it was elegant. In practice, it meant building dozens of enormous dams in some of the most isolated, challenging, and politically fragile territories on the African continent. And that was just the beginning of the complications. When the Transaqua plans first circulated among the broader engineering and scientific community in the 1970s and 1980s, the reaction was not exactly enthusiastic applause. French and Italian specialists who reviewed the designs reportedly called the creators mad, and that reaction was not entirely unfair given what the blueprints were actually proposing. The canal route would require clearing and excavating through thousands of kilometers of dense equatorial rainforest. The construction would demand millions of workers, thousands of heavy machines, and a logistical operation of a complexity that rivals anything humanity has ever attempted. The cost estimates that emerged from early analyses ranged from a mind-bending $14 billion on the optimistic end to $50 billion or more when the full scope of infrastructure was accounted for. For context, most of the countries this canal would pass through have annual government budgets well below $1 billion total, so the project was filed away. It appeared in academic papers, resurfaced periodically at international conferences, and became one of those grand engineering concepts that experts reference when they want to illustrate the outer boundary of what human ambition can conceive. For decades, Transaqua lived in the space between vision and fantasy, too expensive to build, too complicated to coordinate, and too politically sensitive for any single government to champion. Meanwhile, the crisis it was designed to address kept getting worse. Lake Chad sits at the heart of the problem. To understand why engineers and environmentalists are so desperate to find a solution, you have to understand what has happened to this lake over the past 50 years, because what has happened is nothing short of a slow-motion catastrophe. In the 1960s, Lake Chad was one of the largest freshwater lakes in Africa. It covered roughly 25,000 square kilometers, fed fish that kept millions of people alive, provided water for enormous agricultural operations, and served as the economic backbone of an entire region. The lake was so large that people who lived on one shore could not see the other side. It was a genuinely inland sea. Today, Lake Chad has shrunk by approximately 90%. 90%. What was once a vast body of water is now a collection of shallow puddles, shrinking marshes, and cracked mudflats. The fishermen who once sailed across open water now walk across land that used to be the lake bed. The villages that once lined prosperous fishing shores are now surrounded by desert. The causes are interconnected and devastating. Climate change has reduced the rainfall that fed the lake's rivers. Population growth in the surrounding region has led to massive increases in irrigation that drain water before it can reach the lake. And once the lake began to shrink, the cycle accelerated. Less water meant less moisture in the local atmosphere, which meant less rainfall, which meant less water flowing in, which meant the lake shrank further. More than 30 million people live in the Lake Chad Basin today, and their lives are directly tied to the lake's survival. The UN and various humanitarian organizations have described the lake's collapse as one of the worst environmental disasters in the world, driving conflict, displacement, and food insecurity across a region that was already struggling. Some analysts have drawn direct lines between the lake's disappearance and the rise of extremist violence in the area, arguing that when people lose their livelihoods and their land to the desert, desperate choices follow. This is the context in which Transaqua stopped being a curiosity and started being discussed as a genuine solution. Not a pipe dream, but a potential lifeline. Then China showed up. In the early years of the 21st century, as Beijing was dramatically expanding its economic footprint across Africa through investments, infrastructure loans, and development partnerships, Chinese state-owned construction corporations began looking seriously at the Transaqua blueprints. The timing was not a coincidence. China had just spent years executing one of the largest water diversion projects in history on its own soil, the South to North Water Diversion Project, which redirected billions of cubic meters of water from the Yangtze River to the dry northern regions of China via 3 massive canal routes spanning thousands of kilometers. That project gave China something no other country on Earth possessed: actual, hard-won expertise in building exactly the kind of infrastructure that Transaqua required. Chinese engineers had done it. They had the equipment, the methodology, the project management systems, and crucially, the political will to consider doing it again somewhere else. Major Chinese construction firms entered into discussions with the Lake Chad Basin Commission, the intergovernmental body that coordinates water management among the countries surrounding the lake. Real money was committed to feasibility studies. International conferences were held. The Transaqua concept was dusted off, updated, and placed on the desks of African heads of state for the first time in decades. Not as an academic thought experiment, but as a concrete proposal backed by an investor with deep pockets. For the countries involved, nations that had been watching their water vanish and their populations suffer for decades, this felt like salvation finally arriving. The idea of China financing and building this canal was electrifying to many regional leaders who had spent years begging for international attention that never came. But with China's involvement came a different set of concerns that independent economists and development experts raised loudly and immediately. The pattern critics pointed to is sometimes called debt trap diplomacy, and it goes roughly like this. A country without the capital to finance major infrastructure accepts large loans from Chinese state institutions to pay Chinese construction firms to build the infrastructure. The infrastructure gets built, but the loan terms are often structured in ways that the borrowing country cannot realistically repay. When defaults occur, China gains leverage, sometimes direct control over key assets in the debtor nation. This pattern has been documented, debated, and disputed across multiple continents where China has financed infrastructure projects. Whether it is a deliberate strategy or simply the foreseeable consequence of lending large sums to poor governments is a matter of genuine academic disagreement, but in the context of Transaqua, the stakes are uniquely high. If a Chinese-financed, Chinese-built canal becomes the sole water supply for an entire region, and if the governments of that region find themselves unable to service their debt obligations, the leverage that accrues to the lender is not just economic, it is existential. Control over water is control over life itself. The countries that would benefit from Transaqua could, in a worst-case scenario, find themselves dependent not just economically, but physically on the continued goodwill of a foreign power to keep their fields irrigated and their populations fed. This concern has not stopped negotiations, but it has complicated them significantly, and it is one of the reasons why, despite all the renewed interest and the genuine urgency of the crisis, Transaqua has still not broken ground. The geopolitical complications do not stop at questions of Chinese finance. The canal route itself is a political minefield. The project, as designed, must pass through the territories of the Democratic Republic of Congo, the Central African Republic, Chad, Niger, and Cameroon. Every one of these countries has a seat at the table, a set of interests to protect, and a set of reservations that have to be addressed before a single shovel touches the ground. Negotiating a five-nation infrastructure agreement of this complexity is not like getting neighbors to agree on a fence. Each country wants to know what it gets, what it gives up, and who controls what. The Democratic Republic of Congo presents perhaps the most fundamental challenge. The Congo River and its tributaries are the source of the water, and the DRC's territory is where most of the intake infrastructure would be built. The government in Kinshasa has been notably cool toward the idea of sharing its most valuable natural resource with its neighbors, particularly when those neighbors would be getting the water essentially for free, while the DRC bears the environmental and social costs of the infrastructure. And those costs are not trivial. The construction of the cascade dams and reservoirs needed to make Transaqua work would flood enormous areas of the Congo Basin's equatorial rainforest. Conservative estimates suggest that more than 1,000 square kilometers of forest, ancient, biodiverse, irreplaceable forest, would go underwater. And those forests are not empty. Hundreds of villages, home to hundreds of thousands of people whose families have lived in those jungles for generations, would have to be relocated. The human displacement alone could affect more than 200,000 people, according to some projections, requiring a resettlement program of enormous scale and expense on top of everything else. The DRC also has its own plans for the Congo River. The Grand Inga Dam project, which has been discussed for decades, would make the Congo one of the world's largest sources of hydroelectric power, generating electricity that could serve not just the DRC, but much of sub-Saharan Africa. Any significant diversion of water from the Congo's tributaries carries the risk of reducing the river's flow enough to affect the power generation potential of this project. From Kinshasa's perspective, why sacrifice your own energy independence to send water to your neighbors? These questions have no clean answers. They require political negotiations of extraordinary delicacy, and those negotiations have been going on in various forms for years without producing a final agreement. Diplomats meet, declarations are signed, working groups are formed, and the desert keeps advancing. Setting aside the politics for a moment, the environmental objections to Transaqua deserve their own serious examination, because they are not simply the complaints of people who prefer to admire nature rather than use it. They are grounded in real ecological science, with real consequences for real ecosystems. The fundamental problem is that water is not just water. The water flowing through the Congo's tributaries has a specific chemical composition, temperature, acidity, and microbial population that has been shaped by millions of years of evolution in the equatorial rainforest. The water in Lake Chad, or rather in what remains of it, has its own completely different ecological fingerprint, shaped by a very different environment. When you introduce a massive volume of chemically foreign water into an existing ecosystem, the consequences can be severe and irreversible. The fish species, plant life, and aquatic ecosystems of Lake Chad have adapted to very specific conditions over enormous timescales. Flooding the lake with billions of cubic meters of river water from 1,000 miles away could trigger what biologists call an ecological shock, a sudden dramatic disruption of the chemical and biological balance that the existing species cannot survive. There's a very real risk that instead of reviving Lake Chad, an unfiltered injection of Congo water would produce toxic algal blooms, mass species die-offs, and the creation of a large, stagnant, biologically dead body of water that looks like a lake but functions like a swamp. The cure in this scenario would be worse than the disease. Beyond the lake itself, there are concerns about pathogen transfer. The equatorial rainforest of the Congo Basin is one of the most biologically complex environments on Earth, hosting enormous populations of microorganisms, parasites, and disease vectors. Moving billions of cubic meters of water out of that environment and into new territory is essentially moving those organisms with it. Local populations in the Lake Chad region would have had essentially no exposure to many of these pathogens, and therefore no immune resistance to them. The potential for triggering novel disease outbreaks in already fragile communities is not a hypothetical. It is a documented risk that public health researchers have flagged as deeply concerning. Filtration and treatment systems could theoretically address some of this, but at enormous additional cost and complexity. And throughout the length of a 2,400 kilometer open canal, ensuring perfect water quality management is a challenge that no engineering team has fully answered. Given all of these obstacles, the cost, the politics, the ecology, the logistics, the diplomatic complexity, it is natural to ask whether there are better ways to address the crisis. And the honest answer is, there might be. But the alternatives also have serious limitations. The Great Green Wall is perhaps the most well-known alternative approach. Launched as a Pan-African initiative, the project aims to plant a belt of trees and vegetation 15 kilometers wide and 8,000 kilometers long, stretching from Senegal on the Atlantic coast all the way to Djibouti on the Red Sea. The idea is that trees and plants stabilize soil, retain moisture, reduce wind erosion, and gradually push back the advancing desert through ecological restoration rather than hydrological engineering. The Great Green Wall is real, it is ongoing, and in some areas it has produced genuinely promising results. But progress has been slower than hoped, funding has been inconsistent, and the scale of the intervention remains far smaller than the scale of the problem it is trying to address. Planting trees cannot restore a lake that has lost 90% of its volume. And trees need water to grow, which in a desert environment creates something of a circular problem. Beneath the eastern Sahara, there is another potential resource, the Nubian sandstone aquifer system, one of the largest known fossil water reserves on Earth, containing an estimated 150,000 cubic kilometers of ancient groundwater accumulated during a wetter geological period thousands of years ago. Libya has already been tapping into this resource through its Great Man-Made River Project, one of the largest irrigation schemes in history. Egypt, Sudan, and Chad also have access to this underground reservoir. The problem with fossil water, however, is that it is not being replenished at any meaningful rate. Once it is gone, it is gone. Drilling artesian wells across the Sahara and irrigating fields with ancient groundwater is buying time, not solving the problem. And the rate at which the aquifer is being drawn down in existing projects suggests that in some areas, the resource could be significantly depleted within a matter of decades. This is why Transaqua's supporters refuse to abandon the concept even as the obstacles mount. In their view, the alternatives are either insufficient in scale, unsustainable in the long term, or both. Only a genuinely large-scale intervention in the water cycle, moving real, renewable water from where it is abundant to where it is desperately needed, addresses the problem at the level the problem actually exists. There is one more dimension of Transaqua that rarely gets the attention it deserves, and it may ultimately be the most important argument in favor of the project. The transportation dimension. The canal, as designed, is not just a water pipe. It is a shipping route, a navigable waterway nearly 2,400 kilometers long, cutting through the heart of Africa, capable of accommodating large commercial barges and connecting regions that currently have essentially no practical transportation links to each other. This matters enormously for a simple economic reason. Many of the countries in Central and Sahelian Africa are among the poorest on Earth, and a significant part of their poverty stems from isolation. There are no reliable roads. There are no railroads. Goods produced in the interior of the continent, agricultural products, raw materials, manufactured goods, cost a fortune to transport to ports because moving them requires traversing hundreds of miles of unpaved tracks that are impassable in rainy season and brutal in dry season. This transportation barrier means that local economies cannot develop, that farmers cannot access markets, and that the cost of basic goods is astronomically high for people who can least afford it. A navigable canal from the Congo Basin to Lake Chad would not just bring water, it would bring commerce. It would bring access. It would connect communities that have been economically severed from each other by geography and the absence of infrastructure. New ports would develop along the canal route. Trade would flow. Industries would follow the infrastructure. And the transformative effect on human development in some of the most deprived regions on the planet could be genuinely historic. Think about what the construction of major canals did for other parts of the world. The Suez Canal did not just shorten shipping routes, it transformed the economic geography of an entire region. The Panama Canal altered global trade patterns in ways that are still playing out more than a century later. A trans-African canal connecting the Congo Basin to the Sahel would be, in the words of those who have studied it most carefully, not just an engineering project, but an economic revolution. This dual-purpose nature, a water carrier and trade route simultaneously, is what makes Transaqua qualitatively different from simply building a bigger irrigation system. It does not just solve the water problem. If it works as envisioned, it addresses the transportation infrastructure deficit, the economic isolation, and the food security crisis in one interconnected intervention. That is the argument that keeps bringing engineers and politicians back to these blueprints, no matter how many times the project stalls. So where does all of this leave us? After 50 years of proposals, studies, diplomatic negotiations, geopolitical maneuvering, environmental warnings, and cost estimates that keep growing, is Transaqua any closer to becoming reality? The honest answer is closer than it has ever been, but still very far away. China's involvement brought resources and technical credibility that the project never had during its earlier phases. The feasibility studies that Chinese and international firms have conducted provide more detailed engineering analysis than existed before. The political conversations among the 5 countries involved are more advanced and more sustained than at any previous point. The urgency driving those conversations is real. Lake Chad is not getting larger, the desert is not retreating, and the human suffering in the region is not diminishing. But the fundamental obstacles remain. The DRC has not given its full consent. The financing model that protects the sovereignty of the countries involved has not been finalized. The ecological management plan that would prevent the canal from destroying the ecosystems it is supposed to save has not been fully developed. The security arrangements for protecting thousands of kilometers of critical infrastructure through politically volatile territory have not been worked out. And underneath all of those specific issues lies a deeper question about values and priorities that no engineering blueprint can answer. When we intervene in natural systems at this scale, we are making a bet that human ingenuity can manage the consequences of that intervention better than nature managed the original system. Sometimes that bet pays off, sometimes it creates new catastrophes that dwarf the problems we were trying to solve. The history of large-scale hydrological interventions is not uniformly encouraging. The diversion of rivers feeding the Aral Sea in Central Asia turned what was once the 4th largest lake in the world into a toxic wasteland in just a few decades. The damming of rivers around the world has produced enormous amounts of electricity and irrigation water, and also wiped out fish populations, triggered ecosystem collapses, and displaced communities on a scale that was not anticipated in the original planning. None of this means Transaqua should not be built. It means the decision deserves the full weight of its implications. It deserves scientific rigor, transparent democratic deliberation in the countries affected, independent ecological assessment, financing structures that protect rather than exploit African sovereignty, and genuine consultation with the indigenous communities whose forests and villages would be transformed or drowned. What is happening at Lake Chad right now is not abstract. Children are growing up in communities where the fish are gone, the fields are sand, and the nearest source of water is a day's walk away. Families are abandoning villages that their great-grandparents built because the land no longer supports human life. Young people with no economic future in their home regions are being driven into the arms of extremist groups that offer identity and purpose when the legitimate economy offers nothing. The Sahara is winning, and the margin by which it is winning grows a little wider every year. Whether Transaqua is the right answer to that crisis, or whether better answers exist that do not require flooding 1,000 square kilometers of rainforest, navigating the political interests of 5 fractious governments and betting billions of dollars on the ability to manage a continent-scale ecological transformation, is a question that scientists, engineers, economists, and the affected communities themselves are still working through. What is not in question is the urgency. The people living at the desert's edge cannot wait for perfect solutions. They need water, they need land, they need futures. The Congo River does not care about any of this. It just keeps flowing, thundering toward the Atlantic, carrying more fresh water than most of the world will ever see. Whether some of that water eventually finds its way to the Sahara, whether the engineering audacity behind Transaqua is ever matched by the political and financial will to make it real, may be one of the defining environmental and humanitarian stories of this century. The blueprints are ready. The crisis is real. The water is there.